so we went through these. I know we did that. We did these two, right? Here's where we stopped, I believe. Okay, so let's refresh, or I don't know, did we do these? We did do these, okay. Okay, let's look at this one. All right. So here, I've got a lot of stuff going on here, and none of it has just like straight numbers. It's got variables. So remind me when I see this angle right here, D F E. What's the name for that angle? What did we call it? What kind of angle is it? Started with an I. Inscribed. So it is an inscribed angle. So if I have an inscribed angle that looks like this, let's do an easier one. Let's say that this angle right here is 25. What would the arc that goes with it be? What? 25 times 2, so it would be 50, right? So if this angle right here is 4x plus 3, then arc DE would be twice that, right? It's going to be like 2 times 4x plus 3. Okay? Any ideas of how we could set up an equation from here? Which ones? Are those two equal to each other? Is the inscribed angle equal to the arc that goes with it? No, because it's twice right there, so we cannot set those equal. Okay? I agree that these look like they are equal to each other. Does anything tell us they're for sure equal to each other? No. So without something telling us those are for sure the same. In fact, I would kind of know they're not, because like you got 10x for both of them, and one of them's 10x plus 1, and one of them's 10x minus 11, so they can't be the same. So that won't work for this. It does kind of look like there's, in fact, they all kind of look the same a little bit, but if we look at what we're given, we've got this DE is this arc right here, and then FD, the 10x plus 1, is this arc right here, and then FE is 10x minus 11, that's this arc right here. If I put all those together, it goes all the way around the circle, right? What is that, Zoe? That's 360 degrees. So if I add all three of these together, I can set it equal to 360. So that's what we want to do. So we're going to do 10x minus 11 plus, is it okay with you guys? I'm going to go ahead and distribute this. So that's going to be 8x plus 6 plus 10x plus 1. If I add all those things together, I should get 360. Okay, now if you are strongly against solving equations by hand, you could type this into Desmos, f of x equals the left side, g of x equals the right side. But this one's not too bad, so let's solve it by hand. We got 10x, 8x, and 10x. We could put those together. We'll get 28x. Then we've got negative 11, positive 6, positive 1. So negative 11 plus 6 is going to be negative 5, plus 1 we'll get negative 4 equals 360. We will add 4. So 28x is going to equal 364. We'll divide by 28. Okay, 13. There. Our directions, I didn't put good directions on this problem. Let's assume it meant find x since it didn't tell us anything else. Okay, questions? Okay, so this is about like as complicated of that type of problem as you will get. Let's talk about a couple other types of angles. Actually, I'll tell you what, some more types of intersections that we have to look at. Okay, so we looked at central angles and inscribed angles already. Those are going to be the most important, the like key things that you have to have. But there are a few other types of angles that we have to be able to find within circles. So the first type of intersection that we are going to look at is whenever we have two secants or chords that intersect. So if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intersected arcs. And an easier way to remember that is this is the average of the two intersected arcs. So, the scenario that we're looking at here, we've got either secants or chords. The only difference between a secant or a chord is that with a secant, the lines keep on going outside of the circle. What we're looking at here, these are chords because they're just line segments that stop on the edge of the circle. But if it was a secant instead, all you would see different is like the lines would keep going like this, right? So we're just basically looking at any two lines that cross inside of a circle here. So whenever that happens, we've got this line and this line crossing here, and we have got two intercepted arcs. Now notice, this does not go through the center of the circle. If it went through the center of the circle, it would be much easier because they would be central angles, and we would just be able to say, oh, this angle is 88, so this angle is 88, right? These are not central angles. So if I want to find this angle here that they're asking me for, I have to add the arcs together and divide by 2. So I'll do 88 plus 66 divided by 2. And in that case, I'm going to get, let's see, 154 divided by 2. Is that right? Let me just look. And then when we divide that by 52, we will get 77 degrees. You should get a number that's somewhere between the two arcs that you have, right? Because it's the average of those two arcs. So like if I got 154 for my answer, I know I did it wrong. It's too big. It's bigger than the biggest arc, right? So like, for example, on number 10, Carson, what's the lowest number you could possibly get for the answer for number, well, let's say it was asking us for this one here. Like, I can't get a number lower than 64, right? What's the biggest number it could be? 118. It's got to be in between because it's the average of those two. Now, this one is a little bit different because I need to do that. I need to do 118 plus 64 divided by 2. And whenever I do that, that's going to give me 182 divided by 2, which is going to give me 91. But 91 degrees, if we're talking about this arc and this arc, 91 degrees is this angle. Right, and this angle. Both of those are 91 degrees, right? It didn't ask me for that angle. It asked me for this angle over here. So, Carson, what would I do different for this one? Any ideas on that? It's a like simple one-step thing. It's not. We're not going to divide. Okay, I think you guys are just throwing all four of the major operations out there. Since out of process of elimination. Subtract is the correct answer. What are we subtracting? So look at this right here. The angle they're asking us for and the 91 that we have right there, right next to each other, and they make a line. How many degrees are in a straight line? 180. So we're going to do 180 minus 91, and that should give us 89 degrees for that one. Okay, questions? Even though that's not half of a circle, the two angles next to each other add up to 180 when you have a straight line like that. Okay, questions? So this will be how you do numbers 17 and 18. 19 and 20 are actually inscribed angles. Then let's look at this one. We have a secant tangent intersection. Okay, a secant tangent intersection. So if I look at that first picture, and I want to like just label these, which line would be my tangent line? That 128 is an arc right there. CB is not the tangent here. How many times does the tangent touch a circle? One time. So we need the line that only touches one time. So DE right here, this is your tangent. And technically right here, you could call this right here CB. Could be, really it's a chord, but it, you know, if it kept on going, like if you put an arrow on the end, it would be a secant. So a secant passes through the circle. A tangent's only going to touch it one time on the outside. Okay? So, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is equal to half the measure of its intercepted arc. So this problem here says find angle CBD. So CBD is this angle right here. Now that is not an inscribed angle because an inscribed angle has to have both of its endpoints on the circle, but its vertex is on the circle. These work just like inscribed angles, right? So the arc that goes with this would be this arc right here. And they work just like inscribed angles, so if that arc is 128, we're just going to do 128 divided by 2, and we'll get 64 degrees right there. Okay, so if we look at 12, it's asking us for arc BFC. So arc BFC goes all the way around here. Do we have the angle that goes with arc BFC. We do not have that, right? We've got 59. This angle over here, we know, let's switch colors. We know this angle right here, but we don't know the angle that goes with that blue arc. But could I find the arc that goes with 59? I could. What would I do? Just double it. So if I do 59 times 2 right there, I'll get 118. Okay, any ideas how to find what we want now? Okay, we're going to subtract that from 360 because basically these types of problems just split the circle into two pieces, right? So if we do 360 minus 118, then we will get 242, which will be the arc that they're asking us for there. So secant tangent intersections, when that vertex is on the edge, they work just like an inscribed angle, even though technically they're not an inscribed angle. Does that make sense? All right, we got one more scenario. I think it's just one. Yeah, got one more scenario that we have to look at. And these are exterior intersections. So you have, it could be two secants, two tangents, one secant, one tangent. But basically you got two lines that go through the circle somehow and they cross on the outside. Okay? So if secants or tangents intersect on the exterior of the circle, then the measure of the angle formed is equal to half the difference of the intersected arcs. Okay. Now, of these, I think 13 is the easier one to do. 15 is probably the next easiest. 14 is the hardest problem to do. So, if we are finding an angle on the outside of a triangle, we are not going to take the average like we did when they crossed on the inside. We take half of the difference. It's almost like finding the average, but we subtract and divide by 2. So, the intersected arcs here are 77 and 28. So if I want to find this angle out here on the outside, then I would need to do 77 minus 28 divided by 2. So if I do 77 minus 28 and I divide that by 2, 49 divided by 2, that is going to give me 24.5 degrees. Notice that the answer that I get is smaller than either one of the arcs. That should happen right there. Okay, does that make sense? It's similar to what we were doing on the ones that crossed on the inside of the circle, but those were, we add together, divide by 2. Here we got to subtract, divide by 2. Let's skip over to 15 because I think 14 is the hardest one to do. For 15, I need to subtract and divide by 2, but they only gave me one number. What could I do? Good. If I do 360 minus 109, then that is going to give me 249, 51. Oh, yeah, my. Okay, so that's this outside arc, right? We've got this arc right here is 251, and then we've got this inside arc is 109, right? And because that adds up to be the whole circle in this particular case, we can just subtract from 360. So if I do here 251 minus 109 divided by 2, I'll get my answer. So 251 minus 109 is going to be 142 over 2, which is going to give us 71 degrees. So this angle right here is 71 degrees. Notice it is smaller than both of the arcs that we had. That should happen every time. With the ones that cross on the inside, our answer should be in between the two arcs that we have. Here it should be smaller than both of the arcs. Okay, now 14 is the trickiest one of these all, because we don't have this smaller angle, right? And do we have any way of really finding it other than like this? Like, I can't just like double 34, or there's not a simple way of finding it, right? Because that's not half of the circle, so I can't do like 180 or 360 minus 114. I'm kind of stuck. So you're going to have to set up an equation for this. Where it's got that question mark, I'm going to treat that like my x. So if I'm going to solve this, what I should do is I should do 114 minus x divided by 2. And that will give me the answer, which is the angle on the outside, which is what? 34. So I can't really think of a better way than just setting up an equation for this. So you could definitely use Desmos to solve, but it's not too bad to solve, even though it looks kind of scary because it's a fraction. What would I do first if I wanted to solve that? Times by 2 to get rid of that 2 in the bottom. Okay, then I'd have 114 minus x equals, so that's going to be 68. Okay, Joey, what would I do next to solve that? Subtract the 114. Make sure you don't lose your negative with your x. So 68 minus 114 is going to be negative 46. And then, Richard, what's the last thing you would do there? Divide by negative 1, which just changes us back to a positive 46. So this is 46 degrees right here. And if you're not comfortable solving that equation, it's fine. F of x equals 114 minus x over 2, and g of x equals 34. Set it equal to each other. Put it in Desmos, solve it that way. Okay, we good here? All right, so that covers all the rest of the worksheet. So you got about 15 minutes. I want you to work on finishing these up. I'll be around to help if you have any questions. If you don't get it done, it is due on Wednesday, so make sure you get it finished by then.